True or false, chi-square distribution is symmetric. In this section, we will study chi-square distribution. And chi-square distribution is different from the normal and t distribution in that, first of all, it's not symmetric. As you can see here, it is skewed to the right. And then it starts at 0 and takes on positive values after that. So it never takes on negative values. Both these properties are different from the normal and the t distribution. Now, one thing which it shares with normal and t distribution, and in fact with any other probability distribution, is that the area under the curve is still 1. Area under any probability curve is 1, whether it's normal, t, chi-square, or anything else. So with this in mind, let's see if we can answer this. Chi-square distribution is symmetric. No, we have seen it's skewed to the right. Chi-square distribution is negative when degrees of freedom is large. No, I just remarked that chi-square distribution can never be negative. A researcher selects volumes of contents of 13 bottles of cough syrup. Assumed sample is taken from a normal population. The 99% confidence interval for the population standard deviation is this. The population standard deviation should be less than 0.047. Does the level of confidence interval for standard deviation suggests that the variation in the volumes is at an acceptable level? So our results of the confidence interval are saying that the level is somewhere between 0.031 and 0.0479. And this requirement says that it should be less than 0.047. So every value in this interval is actually less than 0.047. Or every value in this interval needs to be less than 0.047 in order for this condition to be met. However, we do see that there are values in this interval which are greater than 0.047. So for example, this interval also has 0.0471 in it, 0.0472, and so on. So since there are values in this interval which are greater than 0.047, so no, we do not have it at the acceptable level. In order to have the acceptable level, all this interval values, all the values in this interval should be less than 0.047, which is not the case. So, and that's because the 0.047 is contained in the interval. So you should have an interval which should not contain 0.047, and it should be completely less than 0.047. Find the critical values chi-square 1 minus alpha by 2, chi-square alpha by 2 for a 99% confidence level, sample size 30. So as always, when confidence level is given, that's the in-between area. So until now, we have done such problems with a normal calculation, with a normal distribution and with a t distribution. Now, this is the symbol for chi-square. This is the Greek letter chi. We have to do this problem for a chi-square distribution. And whenever we are doing critical values for a chi-square distribution, we do the chi-square calculator. So let's see. StatCrunch, is this available from here? Oh, it's available from here also. So let's see. So you would do stats, calculator, and chi-square. And you want the in-between area to be 99%. So remember the last box is the area box, so 0.99. But then the other thing which you need is that, okay, where is the thing gone? It's here. You need the degrees of freedom, and we are given that the sample size is 30. So remember, degrees of freedom is sample size minus 1, so it'd be 29. So 29. And so you'll have 13.121 and 52.336. 13.121, 52.336. So take a note of the symbols here. This chi-squared 1 minus alpha by 2 is for the lower value, and chi-squared alpha by 2 is for the higher value. That's just a notation which you have to remember. There's nothing mathematical about it. And then if you remember such problems for the normal or t, they were asking for only one critical value. Although they could ask for two critical values in those problems also, but they did not. And the reason why they were asking for only one critical value is that over there, the situation was symmetric. So like if you got 2.3 as the positive value, the other one came out to be negative 2.3. So once you know one of them, you know that the other is just a negative of it. That's why they were just asking for the positive critical value because of the symmetry present. But chi-square is not a symmetric distribution. Therefore, anytime you will be asked critical values in a chi-square distribution, it will always be two of them, because one value does not tell you what the other will be. They are completely different. And so, yeah, that's all there was here. Check the answer.